Welcome to the Walton Pie. Today we are going to be talking about Caesar ciphers. Caesar ciphers are one of the simpler ways to encrypt a message, and they are called Caesar ciphers because Julius Caesar reportedly would use these in his personal letters. So to start off with a Caesar cipher, we take our alphabet of letters, so maybe in English we are going to use the letters A, B, C, and so on, and we assign each letter a number, starting at 0 and then increasing by 1 for each consecutive letter. So in English, we would assign 0 to A, 1 to B, 2 to C, and so on and so forth until we get to 25 to Z. This is going to be our alphabet when we use a Caesar cipher. Every letter corresponds to a number. So if you're curious about what different letters would go to under this alphabet, here's a table that you can reference if you are trying to do a Caesar cipher on your own. So, if we were to try and encrypt the word Caesar, the first step is we are going to figure out what number does each letter represent. So, using our table, we can see that C is a 2, A is 0, E is 4, S is 18, A is 0 again, and then R is 17, which is what we have here. So, once we have converted all the letters in our word or our message into numbers, we're going to choose a shift value, which is called the key. We are going to be writing it as beta because this is going to be similar to an affine cipher, which I will have a video out shortly. And so once we have our key, that can be any number from 1 all the way to the number of letters in the alphabet minus 1. So in English, our key is going to be anything from 1 to 25. You could have it be 0, but that's not changing anything, so there's no real point in having that as a possibility. So, in our example with the word Caesar, let's say that our key is beta equals 1. Once we've chosen a value for beta, we're going to add that value to every number in the plain text. The plain text is this series of numbers 204, 18, 17, which represent the numbers corresponding to the letters in our original message before we've changed anything. So once we have our key value beta, we add beta to every number in the plain text. So here our key is beta equals 11, so we will add 11 to every number in the word Caesar. So we get 2 plus 11, 0 plus 11, and so on. And we get the numbers 13, 11, 15, 29, 11, and 28. Now, each of these is going to represent a new letter. But you might see a problem. A couple of these letters are bigger than 26. So, to solve that, we are going to be subtracting 26 from any numbers that are too big until we get a number that is less than 26. So, something from 0 through 25. If you're familiar with integer arithmetic, this is just adding modulo 26. If you would like to learn about more of that, check out the video in the card. So, Caesar, which was originally 204.18.017, has turned into the encrypted text, or the cipher text, 13.11.15.3.11.2, which, when we turn those back into letters, we get Encrypting, which is hard to say, but fortunately we just have to be able to read it. So NLPDLC is the word Caesar, under the Caesar cipher with beta equals 11. So let's say your friend who likes to send messages in code gave you the message JHLZHY, JHU, IL, JYH, JRLK, and whispered that his favorite number was 7. How might you decipher this? Well, odds are this is probably a Caesar cipher. So, if we can figure out the key that was used to encrypt it, we should be able to unencrypt it, or to decrypt it. Now, the way that we can go about and decrypt a Caesar cipher is actually just a Caesar cipher with a different key. So if we were adding 7 to every number to be able to encrypt the message, to decrypt, we would want to subtract 7. Or, if we are doing this modulo 26, we can add 26 minus 7. So, if you're trying to decrypt something, you always have to find your inverse key, or your inverse shift value, which is going to be the number of letters in the alphabet minus your original key. So in English, there are 26 letters in the alphabet, so we do 26 minus 7 to get 19, which is going to be our inverse key. So we will then add 19 to every number in this message, and we will get our original message. If you would like, pause the video and give it a shot, see if you can figure out what the plain text message was. Hopefully, if you were wanting to figure it out, you were able to have enough time to do that. So, after you've deciphered it, you found that it said Caesar can be cracked, which is a little concerning. You wanted your message to be secure with the Caesar cipher. So how might someone be able to break a Caesar cipher if they don't know the key? The trick is, as soon as you know the key, you can solve the Caesar cipher. So most of these methods are ways to try and figure out the key given a specific message. So, you're trying to think of different ways that you might be able to find a key. You decide to go and visit your friend Evan, along with his girlfriend Emma. And then Evan suddenly has to go to the bathroom, as happens during the day. And then while he's in the bathroom, you and Emma discover a piece of a torn note tucked into a drawer. And it says this: FHE, FEIU, JE, UCCQ, EDC, and then the paper's ripped off from there. But you see that Evan has already started to decipher the message. He's already written a P under the letter F. How might we be able to use this to figure out the key? Well, if you know that F becomes a P, you can start with the value of F and then the value of P. So F is 5 and P is 15. So the key to decode it is going to be 15 minus 5, so the way to be able to go backwards. We know that we added 10 everywhere, so we are going to have to either subtract, decode this piece of paper. Understandably, Emma starts to get pretty excited when she sees that the first 4 words in this message were proposed to Emma on, and then it just says M. So is this Monday? Is this May? Is this March? She has no idea, but she's getting pretty excited. So, knowing that she's about to ask Evan some questions that might be a bit awkward and you don't really want to be there for it, you politely excuse yourself, happy for them, but you're a little concerned at how easy it was to crack that code. So let's say you get home and you find a Caesar cipher, but you don't have any letters or keys that you already know. How might you be able to crack this? Well, one way is you could just start guessing all of the different possible keys. I mean, if it's in English, there's only 26 possible keys. So you could just try all 26 to see which one gives you a correct message. However, sometimes you can be able to crack it a little bit faster. If you look at the message, you notice that they left spaces in. So you can see that the first word has 4 letters, the second word has 1, the third word has 6, and so on. But how many English words actually only have 1 letter? There's only 2. The word I and the word A. So that means we can eliminate all but 2 of those possible keys. We know R is either A or it's I. So instead of 26 keys, there's only 2 keys, which means that it's a lot faster to crack this. For that reason, a lot of Caesar ciphers will remove all spaces before or after encrypting, along with removing any punctuations like commas or periods, because that gives people trying to crack the code additional clues that you don't want them to have. So, give it a shot, try and crack it, if you want to, of course. Hopefully you were able to enjoy this video on Caesar ciphers. I'm going to be continuing to make some other videos about other types of ways to encrypt messages, so feel free to stick around and watch some of those. I hope you enjoyed. If you have other questions of different math, feel free to leave them in the comments and I will be happy to make videos about that. Have a good rest of your day and enjoy your math and enjoy some cryptography. Have a great one. See ya.